Hi, my name is Bob Greenyer and I'm a volunteer with the Martin Fleischmann Memorial Project. So welcome this 3rd of October 2024 for this impromptu discussion on the system presented in a pre-recorded video today on eCat World and on the website of Andrea Rossi. Can anyone hear me? Am I actually streaming? Can you let me know if you can hear me? Before I go ahead too much. Wonderful. Hi, Gordon Doherty. Hi, Vanilla Isis. Hi, Stephen F. Hi, Artifact and EBB. Quad 10, excellent. It's being a bit weird streaming software tonight, so hopefully it doesn't give up. I will be recording it locally. If there is a problem, I can upload it. So this is the view in the presentation room when Rossi is talking about what caused the 1 year almost or thereabouts delay in the EV, that's electric vehicle, test with the eCat Never Give Up. And he is describing here why that was, and apparently there was an explosion. It was clarified later that this was somewhere between the two batteries, or one of the batteries that was involved in the system. He was loading it quite hard with a test load in preparation for shipping it over or coming over or doing something with it so that it could be integrated into the Twizy. And it blew up. And he said it was like a bomb and so on. Now, someone said in the comments on Remote View that at the time it wasn't quoted to be a bomb, but maybe he didn't want to talk about it then. We obviously don't know. I'm sure he would have taken pictures for insurance, maybe. It would be great to see those and understand what actually happened with a little bit more clarity. But let's take his word for it and say that there was a bomb and that he had to modify the device such that it was, in his words, which he likes to use so often and I like to use so often, safe. So it had to be modified for safety. But he said that the explosion caused him to change the weight of the box from 10 kilos here to around about 90 kilos. And so we're going to address that. And the principal claims of the pre-recorded video was that the unmodified car had a battery charge of 96 and it went to 0%, and in that time it managed to travel 73 kilometers. The modified Twizy started with a charge of 62.18% and it went to 83%, and it traveled a distance of 201 kilometers. So that isn't really 3 times, but one consider that it could probably go 3 times given the fact that it has 83% charge, which is bordering on the starting charge of this. I have to say that if this is actually true, it's freaking awesome, and congratulations to Andrea Rossi. It would make my job a lot easier. I could focus on nuclear remediation and seed germination improvement and crop growth improvement and anti-gravity and materials processing and the wind hex, all those lovely things. We could stick the eCat as the electricity generator for certain purposes, and we could then forget about the Vega based energy generator. Well, it is 100 kilograms, so maybe not. It is limited to 10 kilowatt units. 10 watt units, is it? Yeah, 10 watt units. I think. Is that right? And the situation is still the same as it ever was, that he wants to sell 1 million 100-watt equivalent units before anything will go ahead. Absolute terrible situation, in my view, to be doing that. And, you know, it's disappointing. But what was said in the conference, which was quite short, and actually what was able to be said was even shorter because of the translation going on and the confusion in the translation and so forth. So it's actually quite quick to go through and review those materials, but I've done that review, and yeah, so 10 watts and 100 watts is Stephen F. is confirming. Yeah, so they can be pre-ordered, but he says manufacturing will only go ahead when there is 1 million 100-watt equivalent units of orders. Well, sorry, 1 million. So that's 100 million watts basically ordered. So, well, okay. Right. So I'm going to go through a couple of numbers here and just see if we can test the claims of the engineer in the room, who basically, there was this engineer, he reached out to Rossi based on the parameters that were being promoted for the ECAT at that time, and said, look, I've got this Twizy, I think it's a good fit, I already am skilled at being able to modify it so that I can put other batteries or whatever in there. I think I'm your man. And there was an agreement made, and ultimately that led to the test recently. And so I'm going to look at the numbers, and we're going to see if his belief that it was impossible to have something in the space and weight that will be able to provide the energy required is actually valid. And there are already some people that are talking about new battery technologies and so forth on ECAT World. You can go and have a look at that, where it might be possible just with different battery technologies. But, you know, some of these battery technologies aren't actually available right now. So one could argue that possibly that is not the way that this could be challenged. Anyway, so I have done a little bit of thinking here. So from my looking at online resources, the battery was a 6.1 kilowatt hour lithium ion battery. This is actually stated also by them in their press conference. The nominal range is 90 kilometers. However, that might be for a different rated one. This was the cargo version, which has an area for taking weight rather than a cargo, rather than actually a second seat, as far as I understand it. So it might have a different range. I think it was 80 kilometers maybe. But anyway, I make some assumptions here. The first assumption is this, that assuming the 6.1 kilowatt hour lithium ion battery draining and charging linearly. So the following rough calculations assume that when the battery, the lithium ion battery, is draining and it is charging, it does that in a linear fashion. So with that assumption in mind, if we look at the unmodified car at 96%, its starting stored power is at 5.856 kilowatt hours. You can just times 0.96 by the rated capacity, and that gives you that. And then that kilowatt hours gave 73 kilometers as it went from 100% to, whatever it was, 93% or something, to 0. Therefore, 80.219 watt hours for 1 kilometer. So we can do a quick maths to say that, like, what would need to be used to take the, assuming it was the same weight. Now, there is the point that the modified car had an extra 100 kilos, but they don't consider that in their equations. I'm not considering it here. it will make a difference. It's like a fairly large person sitting in the back seat, and they were weighed. But anyway, the two vehicles were weighed, and there were 100 kilograms difference between the two. But anyway, if we've just assumed that we took the same car and we drove it for 201 kilometers, that would require 16.128 kilowatt hours to do that 201 kilometers. And so if we look at the modified car, that started out at 62.18%. And so its starting stored power based on the nominal rated power is 3.792928 kilowatt hours. And at the end of the run of the modified car, it was at 83%. So there was an additional 20.82% of the rated capacity, or 1.2 kilowatt hours, put into the battery. So the total for the power generation is the amount it drove plus this extra 1.2 kilowatt hours, which gives us a figure of 17.394 kilowatt hours. So based on this assumption here and the fact that we're discounting the weight, the power generation from the ECAT was 17.394. Here's some points that were taken out of the presentation. The initial weight of the ECAT before the explosion was about 10 kilograms, according to Andrea Rossi. After the explosion, where the box weighed about 10 kilograms, it went to a box that weighed nearly 90 kilograms, and this was claimed for the purpose of safety, and so it could not be tampered with. So all in all, the engineer reported that the ECAT was around 87 to 89 kilograms, and that his integration electronics was about 8 to 9 kilograms, and the total approximate weight, as on the weight scales, came in at about 100 kilograms. Well, even if I add 90 kilograms to hit 99 kilograms, it's still not quite 100, but it's pretty damn close. So let's say it's 100. Now, the engineer stated that it was his belief, since that the actual stock 6.1 kilowatt hour lithium ion battery weighed 100 kilograms, and of course the overall package, including all the electronics and everything, weighed 100 kilograms, that he couldn't see any way that the car could be powered for the extra time, which is effectively 200. Well, it's all of that generation that we talked about in the previous slide here. This generation of 17.394 kilowatt hours, which, if you look at that, it's almost 3 times the rated power of the battery, and it's still got 83% left. So it's basically tripled the capacity of the battery. He didn't believe that could be done in a 100 kilograms unit. He also noted that he did not see the inside of the ECAT. So as far as I can work out, what happened is there was an agreement made between them that this would go ahead, and they kept on exchanging emails, and it says, well, what are you going to give me? And Rossi might have said, well, I'm going to give you this many volts at up to this many amps. And he said, well, maybe I need this or maybe I need that. And they decided on, what was going to be provided out of the black box. And he then built the electronics to handle the input power that was coming from this unseen black box. Okay. As we know, in the past, Rossi has had vents on his ECATs and fans in there to keep them cool. I didn't see any pictures of the device. I imagine that it would have similar equipment in there to have airflow going through. But that being said, what in the world could provide this kind of power in this kind of system, other than batteries that are not necessarily available? Well, there possibly is one thing, and that is hydrogen. And because hydrogen has an energy density of approximately 33.3 kilowatt hours per kilogram. And so to determine how many kilograms of hydrogen are needed to produce 17.394 kilowatt hours, you can use the following calculation. And so I've done it here, energy required, energy density, there we go. We need just over half a kilogram of hydrogen. And of course, if we've got airflow through, then we have the ability to, and sorry, this is the where you can find the facts and figures here, hypertextbook.com facts/2005, michelfung.shtml. So yeah, we're looking to get 522 grams of hydrogen. And if we've got air being able to flow through this device, we can use a fuel cell, and you would need 522 grams of hydrogen to produce this 17.394 kilowatt hours of energy in a fuel cell. And because we know from earlier that the rated discharge is 80.219 watt hours to do 1 kilometer, okay, then to achieve what was done, I guess, you might be able to, oh, sorry, I've given the game away now. You might be able to get away with a 100-watt unit, and given the fact that he was claiming that this was a 100-watt output made of 10 10-watt units, the output of this device presumably is able to match the output of this black box using hydrogen. Now, if you wanted to store that in a tank, is there a tank that's possible in the weight that was given, 100 kilograms or even 10 kilograms, that would be capable of storing this amount of material? Well, I'm just going to show you the fuel cell here first, because it's quite nice. It's about $2,000 for this fuel cell. I'm sure there are other ones which you can get, and it's quite small. In fact, if you actually look at the technical details, it is 11.8 millimeters by 10.4 millimeters by 11.8 centimeters by 10.4 centimeters by 9.4 centimeters. So what is that? It's 10 by 10 by 10. It's 1,000. But anyway, it's not very big. I think it could reasonably fit in a fairly large box. And the weight is 400 grams plus 1,290 grams plus 30 grams. So you can see that fairly reasonably you could get that into the space. And for some reason I've lost some slides here, which is tedious. Okay. Anyway, so when you look at that, then what you have is I'm just going to make one slide up here. Somehow I lost a slide. No, there you go. All right, well, basically, I'm going to make this slide up. Give me a sec. It's just on the weight calculation, but you can work it out. Well, anyway, I'll do it on the basis of a tank. So now, can you store enough hydrogen? Well, I happen to have come across this Naval Research Laboratory document. It's actually online, but it's on a Amazon Ores. I don't know whether it should be public, but I got it. So there we go. You can go and ask this person here about this, or you know, it's in this publicly available document. And like I say, it's for the US Naval Research Laboratory. And if we go down here, they've got various UAPs and development of UAPs, and they're trying to develop these radio-controlled things, la 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 la. And then they develop this tank here. Now, we do know the US Naval Labs have collaborated or are aware of Rossi from the point of view that even in the most recent presentations of David Nagal, who worked at the US Naval Labs, they refer to Rossi's ECAT. So here is the development of their hydrogen storage fuel tanks. From 2005, it went up 2.8 times to 2007, and that went up 2.9 times. So by 2009, which is really rather a long time ago, yeah, that's 69 concurrent viewers. I like that number. By 2009, which is what, 15 years ago, they already had a tank, which you can see on the next page here, that was able to store 500 grams of hydrogen in a 22-litre tank, which weighed just 3.6 kilograms. Okay, if you include the regulator, which is 0.15 of a kilogram, that would be 3.75 kilograms. And if you add that to the weight of the fuel cell, 3.75, this is 400, that would be 4.15, and then 5.34 something. I mean, it's so much lighter than the 10 kilograms. So with a fan in there for blowing the air around, a bit of extra electronics, maybe a buffering battery, you could absolutely easily get 511 or whatever it is, 522 grams of hydrogen and the fuel cell and the valves and the fans and the piping inside a container in 2009, at least for the hydrogen storage. Are these commercially available now? Maybe, maybe not. Okay? So 100% certainly, easily within 10 kilograms, you can get this. Of course, it might be quite explosive, but probably not if you had a system like this Navy-based hydrogen storage tank. Okay? So this can deliver the observed effect. Okay? Now, the next thing is, would that be the best way to do it? And if you were Rossi, would actually trying to source a hydrogen storage tank be the way you would do it? I don't think so. I think Rossi would want to power his hydrogen fuel cell from lithium aluminium hydride. He has a lot of experience with lithium aluminium hydride. It's part of his patent for the ECAT. And I did some maths here. I will show all the working on the blog, possibly tomorrow or the day after. But anyway, 1 kilogram of lithium aluminium hydride can produce 79.82 grams of hydrogen. So 6.54 kilograms of lithium aluminium hydride can produce 522 grams. So just 6.54. You need a 7.13293 litre tank. That's a lot smaller. That's a lot smaller than 22 litres to store 6.54 kilograms of lithium aluminium hydride. And the whole weight of the solution minus a tank, so that is the controller for the fuel cell, and all of the lithium aluminium hydride to produce the 522 grams of hydrogen would be 8.17 kilograms. So the balance of 1.83 kilograms could be used for that should say lithium aluminium hydride storage tank, a heater to heat it up to release the lithium aluminium hydride stored hydrogen, a fan to run the airflow through the fuel cell, and relevant piping. So that I need to put that for the actual storage. So just give me a second. Okay, so just to clarify that, if we were using lithium aluminium hydride, after we have the fuel cell, the controller for the fuel cell, and the required lithium aluminium hydride, it comes to 8.17 kilograms. Therefore, you only need you have 1.83 kilograms in the original 10 kilograms to provide all of that energy that is necessary to do the test within 10 kilograms. So, and because this is quite a small volume, you know, you could potentially make a tank, and because the lithium aluminium hydride isn't under pressure, it's stored chemically. It only comes under pressure if you heat it up. And the thing is, if you were driving the production of the lithium aluminium hydride through some electronics that heated the tank to try and keep up with a high current load, you could end up doing a bang like we did when we had lithium aluminium hydride in the the pressure tests that we did in Minnesota many moons ago. And so explosion would be something you might expect. So you would, the way I'm looking at it, this can be done with lithium aluminium hydride easily inside 10 kilograms. And yes, you might want a large thing around the outside in case it became unstable and went boom. I'd like to believe this test, failing my calculations being wrong, which they might well be wrong. I do not think this test is anything to get excited about. I will offer myself to go to Rossi's location and drive a car with one of these devices in it, knowing it might have lithium aluminium hydride. I will take no cameras. I will see before and after the device, internals, and make an assessment as to whether there is anything valid going on here. And I will commit to you that I will tell you the honest truth about whether there is something to get excited about here. I will take no cameras. I will just look inside the box and see if there is the kind of things that I would expect could deliver this. You know, I reckon you could put together a solution that would be a black box that you could give to that same electrical engineer in a very short order to achieve this test. I don't know why the engineer did not think about the use of hydrogen potentially. Of course, you know, if there's absolutely no airflow coming into this box or coming out of this box, then, you know, we would have to rethink what may be going on, and it might be a more interesting proposition. But every single box that I've seen of an ECAT tends to have some sort of airflow going through it. I can't imagine that you wouldn't want some airflow going through it, given the fact that there should be some things under tension, even if it is an ECAT. So, so I don't know what people have to say about that. I just wish it was a better test. I wish the engineer had been able to see inside the device. I wish that it had been a proper open collaboration. I wonder if any of the people that have signed NDAs have actually, thank you Vanilla Isis, I wonder if any of the people that have signed NDAs or are lining up to produce these things have actually seen inside the box. You know, it would be great for Rossi to share those historical photos of the aftermath of the explosion so you could actually see that the battery was exploded, because the story seems to be not always consistent. And so, you know, I want this more than anything. I started this journey on the MFMP because I believed Rossi might have had something back in 2011. I signed up for those 2 heaters, and since then I've replaced my boiler twice. So I really would have liked, is it twice? Yeah, I think I've replaced it twice. I've definitely replaced it once. And I would have liked a boiler for, basically, I would like to have had those 2 boilers, and I haven't got them. It would be fantastic for people like Roger Green to be able to capitalize on the investment they made in Rossi with the licenses he holds. I'd be absolutely made up for that. But as that test stands, with my calculations, which may be wrong, and if they are, I sincerely apologize, but I think they're pretty sound. You can do this with hydrogen and fuel cell easily with lithium aluminium hydride, which I pretty much am certain Rossi has a lot of experience with, knows where to buy it and stuff, and knows how to get it to produce hydrogen. Absolutely, he knows. He knows how to do that. It can be done with those things easily within the original 10 kilograms. And if you overdrove it and you overproduced hydrogen from the lithium aluminium hydride, it would go bang exactly as it did for the MFMP in a video, which you can go and look at on our YouTube channel, which is called Bang, because it heated up and too much gas was produced, and it'll go bang. Three reckons there's actually a hamster running on a wheel inside each box. I put this calculation in the background here. Yeah, you can use aluminium to produce hydrogen. Kind of did that earlier in the year, knowing that. This is another military technology they've explored for delivering hydrogen in the field, but you need to add water, so you would actually have water in there. I was trying to look at a solution that would fit within the original 10 kilograms complete and provide all of the power to complete the test as observed today. Yeah, Estonia's, yes, you do need a exhaust pipe, but that could just be a cooling fan for the electronics. And, you know, if someone wasn't monitoring the water vapor coming out, then what can I say? Yeah, I know the device had a fairly different voltages, but you know you can do a DC to DC voltage transform, and they're not very big these days. They're quite simple. I mean, Alan, I think you would be able to come up with a voltage to voltage DC to DC volt transformer quite readily. These are not complicated things. You can buy them off the shelf. Thank you very much, Gary Johnson. Most of the hydrogen-based cars, and there was an advert in 2001 for, I think, a Toyota or some Japanese manufacturer car that I saw recently. They use these same kind of carbon fiber plastic, polymer, steel type vessels to store the hydrogen. It's a difficult thing to store, but it's just easier if you've got access to lithium aluminium hydride and you know how to evolve hydrogen from it. So if anyone's got any questions on my hypothesis here, which, you know, I hate that this is the case. It could have been so easily avoided. But here we are, yet another test, which for me is essentially meaningless. And we've waited a year and a half for this one, which I don't know whether that's a good amount of time or a bad amount of time, but essentially, there was a 10 kilogram unit that became a 100 kilogram unit, roughly. 89 to 90 kilograms of that was attributed. Sorry, I don't want to block Mr. Rossi's face. I commend Frank Ackland for his efforts here. It's great. I think maybe he did some of the editing on the video. I don't know, but the videos were great. So thank you, Frank, for that. The tests were: one unit goes from 96% to 0, unmodified, travels 73 kilometers. The modified unit goes 62.18 to 83, and it traveled 201 kilometers. So you do the maths, and it turns out that to do the extra kilometers without discharging and indeed charging the battery, you need to produce 17.394 kilowatt hours. Some other people on ECAT World came up with a similar kind of 17 kilowatt hour figure and said that there are potential battery solutions that might be able to provide that in the weight of 100 kilograms that was provided. This is just clarifying the weight and the fact that the electrical engineer who's Twizy, he modified, he didn't think that the 100 kilograms added could ever explain being effectively producing triple the amount of power in the battery as the original 100 kilogram lithium ion battery. But he also stated very clearly that he did not see inside the ECAT, so he does not know what is in there. So no one knows what is in there. If we to do this with hydrogen, you only need 522 grams of hydrogen to do the work observed. Even if it needs to be a fair chunk more than that, then you know, there's plenty of weight to play around with here. You can do that because the output is meant to be rated at 100 watts. This is a 100 watt rated output fuel cell, and it will convert that 522 grams of hydrogen with air, oxygen from the air, into the 17.394 kilowatt hours. This is overrated at 100 watt for the average watt delivery for driving the vehicle for the length of time it did. Now, I suggested that the hydrogen tanks, this one from 2009, able to store 0.5 kilo of hydrogen, and with regulator it comes in at 3.65 kilograms, 75 kilograms. So absolutely easily within the original 10 kilograms, technology from 2009 storage of hydrogen could do it. But I just don't think Rossi would do it like that. I think the extra weight wouldn't be so much of a problem with lithium aluminium hydride, which he has immense amounts of experience with, both purchasing, deploying, evolving hydrogen from it, controlling the evolution of hydrogen from it. Alan and I experienced the blowing up of lithium aluminium hydride way back when we were testing those initial sort of glow stick type tests and the verification of the Lugano reactor. And just 6.54 kilograms of lithium aluminium hydride can provide the required 522 grams of hydrogen, and you need a 7.13293 litre tank to store that amount of lithium aluminium hydride. So the overall weight minus the tank would be 8.17 kilograms. So the balance, therefore, you have 1.83 kilograms within the original 10 kilograms to store that lithium aluminium hydride, provides heater tape for it, a fan for the overall fuel cell, and cooling everything down when it's necessary, and the piping. And so there we go. I think that settles that, and someone's got to do a better job of a test. Gordon, yeah, I mean, when you buy the lithium aluminium hydride is a standard industrial reagent. If you're buying a little bit amount from a scientific supplier, it's going to cost quite a lot. But if you're buying it in industrial amounts for industrial processes, it's not going to be that much. Okay, so I wish I had better news to report today. I really, really, really want it to be true. You know, I had a smart car. I would have preferred to have had an electric smart car. I drove for most of my time in India electric bikes. I was the first person in the state of Kerala with an electric bike. I charged it off a solar panel. I would much prefer that electric bike had an ECAT in there and I could drive it everywhere all of the time without having to charge it. Beautiful. Having a technology that it does what this is claiming to do is absolutely transformational. And I'm determined to see that delivered. I would like Rossi to have done it. It would make my life a lot easier. But what he's done today, I don't think it will convince anyone beyond, oh, that's interesting, let's run the numbers. I'm disappointed that the engineer in the room couldn't work it out. I will retract all of this if someone proves my calculations wrong. Hydrogen is an amazing energy storage material. And yes, it explodes if you overdrive a storage unit from it. Okay, so with that, I will say thank you very much. Buenas noches, dobre noc, good night. I will see you on Sunday for the Crop Circle Part 2. I'm very excited to share with you some interesting things. And I will be streaming again the last day of the Russian conference tomorrow. So if you haven't seen any of that, you should have a look at several of the presentations, have a look, see what you like on the menu. Had a bit of issue with Ed Lewis today. He couldn't get, he was using a web browser version of Zoom and he couldn't get his presentation. I rushed back to where I was streaming from, tried to help him, and then my computer crashed. So I actually lost that end of the stream. But he didn't actually do his presentation. He'll do it later in the year. But I do have his slides. Therefore, and I can tell you, we can update some of his slides with absolutely beautiful high-res images of Matsumoto's work. Look out for the Kickstarter, which I hope to be able to deliver next week. So thank you very much for your time, and I'll see you in the next video.